address. All right. And so the range of the first octet in class A will be a number between 1 and 126. All right. Any number between 1 and 126. Again, 127 is a part of it, but the 127 is used for testing. So you would not assign 127 to a machine. How many persons are familiar with Linux, like the Ubuntu or any of those?
I have an idea, sir.
All right, so if you go onto a Linux, without setting the IP, the default that you will see is like it will show you like the 127, which is just the loopback address. It's just gonna be there just to show you that the network interface card is working. All right. So this we say is a class A, simple because the first octet falls between 1 and 126. All right. Which class is the second one?
B.
Class B. And what's the reason? What's the range of the first octet for class B?
I don't really have that information on the tip of my tongue, but just looking at it, I noticed that the host address, based on what I'm seeing, I noticed that the host address takes up what that would be. How many bits are now? 8 and 8, 16.
Mm-hmm.
So
Are you talking about the subnet?
Yes, sir.
Based on the fact that you have the first two.
Yes, sir.
Being a number over 0. All right. Yes, but what's the range that we have in the first octet?
I don't have that information on the top of my head now, sir.
Anybody would like to assist?
128 to 191.
Right. So once it's a number between 128 and 191, they say that it's a class B. All right. So it's a class B IP address. So this that we have on the screen here, the second one is a class B. Hold on. So, all right. And the third one.
Sir, just a question before you go on to the third one. You're saying that for for class B, is the first octet that's supposed to be between 128 and 191?
Yes.
Okay, thank you.
Mm-hmm. And for class C, oh, I'm sorry. So the third one is class C.
So the third one, sir, I think it's from 192 to 223.
All right, yes. All right. So any IP address that you look on, by looking at the first octet, you can tell which class it actually belongs to.
Sir,
yes?
What was the range for class C again? 192 to what?
Repeat, 223.
223, all right, thanks, sir.
Mm-hmm. All right. All right, now, what you're seeing here over the left side here, these are all network addresses. Now, what's the default subnet mask for class A?
It's 255.0.0.0.
Right. So we say class A IP address defines the network in the first octet. And so in the first octet, you'll find 255, and the others will be 000. All right. So the network is defined in the first octet. That simply means that if you are given a class A IP address and you're asked to write down the network ID for that particular IP address, all you need to do, because the network is defined in the first octet, all you need to do is write down the first number or the value in the first octet, whatever value that is in the first octet, and change all the others to 0, and that will give you the network ID. Because the network is defined in the first octet. All right. So for example, if you guys are given this IP address, let's say 17.12.3 What's the network ID for this IP? What's the network ID for this?
17.0.0.
17.0.0.0.
Exactly. So 17.0.0.0. So just write down because the network is defined in the first octet, just write down the value, whichever value that is in the first octet, and change all the others to 0. All right, and that's the network ID. All right. And we're not talking about subnetting now. We're just talking about the network ID. All right. Similarly, for class B, the network is defined in the first 2 octets. Therefore, if we get a class B IP address, let's say 180.15.2.1. All right, so let's say we have a class, this class B IP address. So what's the network ID?
One 180.15.0.0.
Right. All right, so the network is defined in the first 2 octets. So you just write down the whatever value you have in the first 2 octets. That simply means that any computer, all the computers that are on this particular network will have the same value for the first 2 octets. So if you have 20 computers on this network, you'll have the 20 of them will have their IP address starting with 180.15. The other 2 numbers may vary to whatever they want to use. All right, but this is the network. This is what tells you what the network is. And for class C now, so if you're given this class C IP address 192.168.1.5, what will be the network ID for this? What's the network ID?
192.168.1.0.
Right. Okay, so for this one, it will be 192.168.1.0. All right. And that's because the network in the class C is defined in the first 3 octets. All right, the first 3 octets. You write down the values that you have in the first 3 octets. All right. On the other side, if you want the broadcast address for these IP addresses, you'll simply change all the zeros to 255. So the broadcast address for this, just put 255 there. For this one, just put 255 here, here, here. Similarly for this, you put 255, 255. Is everybody following?
Yes, sir.
Yes, sir.
All right. All right, so for this IP address or default subnet mask, as mentioned before, would be 255.0.0.0. For this one, since the network is defined in the first 2 octets, we have 255.255.0.0. And for this one, the network is defined in the first 3 octets, and that gives us 255.255.255.0. All right. All right. What's the network ID for this IP address?
Ten dot
10.0.0.0.
Okay, good. What's the network ID for this one?
172.16.0.0.
Okay. And this one?
192.168.10.0.
Great. Just so it's as simple as that. So that's how we identify the network IDs. The broadcast IDs, again, all we do is change the zeros to 255. For this one, the network is defined in the first two octets. And so the broadcast address for this would be the 172.16, and the other two octets turn to 255. All right, as you can see there. And again, for class C, the network being defined in the first three octets, we write back down the first three octets for the broadcast and change the last one to 255. Okay, yeah, so that's an error. I need to correct that. All right. Good. So that's how we would represent the broadcast and the network ID. Any question on this so far? Is everybody clear so far?
Yes, sir.
All right. The next thing that we looked at last week, we looked at the use of CIDRs. All right, so we looked at the use of CIDRs. So for example, if we're given an IP address and we see a slash beside it, that simply means we are not using the default, but we are doing what is called subnetting. All right, so there are cases, and you'll have to look out for this. So you might see a particular IP address, like you might see all a class A IP address, and you see a slash, let's say you see a slash 17 beside it, or you see a class not 17, maybe a slash 7, or slash, let me use a small number, slash 8, or slash 9. Or you might see a class B IP address with maybe a slash 18, or a slash 17, or a number like those. You may see a class C IP address, and this is gonna have like a slash 20, something more than 24. If it's 24, it means that you're using a default subnet mask. If it's over 24, it means that you're using a custom subnet mask. All right, so let's say we have these. Just a minute.
If you're doing something on your screen, I'm not seeing it.
Yes, I'm gonna bring it up shortly.
Okay.
All right. All right, so let's say we are asked to determine the custom subnet mask for these. What's the custom subnet mask for the first one? Custom subnet. Anybody?
Is it 255.128.0.0?
Can I say come by the 128?
All right, so the first octet, all 8 bits would have been used. All right, so that would have been 8. And going over to the next one now, that would have been the 9th bit, so to speak. So that 9th bit would have been on, which is going to be 128, and all others would have been off. So that off, that's how we get the 255.128.0.0.
Okay. So you're saying then that the /9 means something. All right. So the /9, everybody understand what the /9 means?
Yes, sir.
Anybody not sure what the /9 mean?
No, sir.
Hmm?
Not
Sir, what
sure.
it mean?
You're not sure?
No, sir.
All right. So there are persons who are not sure. So I didn't catch the name of the person who was talking about earlier. So could you just explain it to those who are not sure what the /9 means?
All right, so we seem I'm a little bit under the weather, it seeds. The /9 speaks to
Oh,
how
that's
much,
Marvin.
right? How much what call it again? Sorry, my chair got jumbled. All right, so let's see. The default for a class A IP we know is default subnet is 255.0.0. The first octet, which means the first part of that subnet, is 8 bits altogether. That's how we got the 255. So see, now we have a /9. What it means that the first octet is actually used for our network, and we're borrowing 1 bit from the immediate octet to make up 9. So it'll be 8 plus 1 give us the 9. So the very first bit going over into the second octet would have been on 1. So that's how we get the 9 altogether. Means that those 9 bits are actually used for network, and the remaining is used for host. So if we should convert that second octet, would have had a 1 with 7 zeros after, which means that would have been 128. We converted to a decimal, thus giving us a subnet mask of 255.128.0.0. If that makes sense.
All right. Is it clear, everybody? All right, just in case it's not, anybody is still not so sure. All right, so the /9 there means that we are supposed to turn on the first 9 bits of the subnet mask. So you're gonna have, this is binary now, so you're gonna have, in the subnet mask, you're gonna have 1, 2, 3, 4, 5, 6, 7, 8. And each octet of the subnet mask can only hold 8 bits. So since I have 8 there, I'm gonna have to put a full stop. And the other one to make the 9 is gonna go in the second octet. So with the first octet of the subnet mask being filled out with pure ones, the second one starts with a 1. There is our 9, and so the remaining values will turn to 0. How many octets do we have per IP address again?
4.
4. And in each octet, we should have how many bits?
8.
8. Therefore, how many zeros are needed in this second octet?
7.
7.
All right, so we need to put in 7 more zeros. 2, 3, 4, 5, 6, 7. All right. And we still need 2 more octets with pure zeros. 1, 2, 3, 4, 5, 6, 7, 8. And 1 more with pure zeros. 1, 2, 3, 4, 5, 6, 7, 8. All right, so what we're saying here is that we are gonna have to now convert these numbers to decimal. So this is in binary. If you were to convert this number to decimal, which number would you get?
255.
255.
All right, so that's the 255. I'll put back the dot and convert this one to to decimal.
128.
But you understand how to convert them to decimal?
128, sir.
Just work the place values. So this is 1, 2, 4, 8,
16,
16, 32, 64,
128.
128. All right. Is that clear though? If you're not sure, we can work it out.
Yes, sir. I'm
Work it. Work. What did I say? You're clear? Or should I work it out?
I'm clear, sir. I'm clear.
Okay, okay, good. All right, so this would be 128. And then the pure 0 would be 0. Pure 0 here would be 0. All right, so that's how we would work out this custom subnet mask based on the slider here. All right, the slash here indicates how many bits should be used for the custom subnet mask. And therefore, our custom subnet mask for this IP address would be 255.128.0.0. All right, based on the /9 that we have here. All right. What would be our custom subnet mask now for the second IP address?
Sir,
Yes.
I think that is 255.255.192.
All in agreement?
Yes, sir.
Anybody disagree? Anybody not sure how he came by that answer? Anyone not sure? Feel free to say you're not sure.
Not sure, sir.
Not sure. All right, so again, just look at the slash, the number after the slash. This is a /18, which therefore means that how many bits are we going to have turned on?
18, sir.
18, right? So let's look at that. So we're going to have 8 bits turned on for the subnet. Not 8, I mean 18. I should have said 18. So it's 1, 2, 3, 4, 5, 6, 7, 8. Each time I reach 8, I have to put a full stop. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 8, that's 16. How much more do we need?
2.
So we need 2 more. And
2
we,
more, sir.
right, and we fill in this other spaces with pure zeros. Two, 3, 4, 5, 6, 7, 8. All right, so the next thing to do now is just to convert this to decimal. Which number is this in decimal? Which number is this in decimal?
255.
255.
Mm-hmm. And the
That's
third
one.
one is what?
192.
All right, so it's, so this is
128
128 plus
plus 64.
64. And that's how you end up with the 192.
Yes.
All right. That 0. So that would be our custom subnet mask. I hope we're all clear with that.
Yes, sir. Sure.
All right. So what would be now our custom subnet mask for the third one?
255.255.255.192.
About 192. All right. So as As you can see, this is 26 bits will be turned on. So we know that every 8 that is turned on is 255. And based on this number, we have 3 8s is 24. So therefore means that the first 3 will be turned on, and then the other 2 would be over in the other octet. All right. Again, if you're not sure about it, you can just write down the bits, write down the 26 bits, and you'll see. All right. So let me just type it on the screen as well. Just erase what is there. So for this one, you need 26 bits turned on. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 3 8s, 24, 25, 26. 1, 2, 1, 2, 2, 4, 6, 8. So that would be our custom subnet mask, which is 255. That 255. That's 255. That 192. All right, so that's what we should have ended up with for this one. Any question?
Nope, sir.
All right. So everybody should be able now to work out the custom subnet mask given a particular IP address. When we are subnetting, however, your broadcast address will be dependent on the particular subnet that you're referring to. But without subnetting, our broadcast address would have been determined based on what we looked at before. All right. So. All right, so this is what we have so far. Let me just clear these. All right, so that's what we have for our custom subnet mask. Given deciders. So once you're given deciders, you have to work out your custom subnet mask. So therefore means that if you see an IP address like this, if you're given an IP address like this and you do the configuration with the 255 or 255.0, it means that it's incorrect. Because the fact that you put that 0, it means that you're not referring to this particular IP address. All right. The /26 is what tells you what the subnet mask is and tells you also which network, which part of the IP address should be used as network. All right. All right. So another thing that we did last week, we would have looked at how to do our subnets. And in particular, we look at how to work out things like the increment for the given subnet. We look at how to work out the broadcast address, the network address, and so forth. So we look at how to subnet in class C, as well as how to subnet in class B. I think we also look at class A, but the idea is the same. It's just that for class A, the subnetting would be done in the second octet, whereas for class B, the subnetting is done in the third octet, and for class C, the subnetting is done in the fourth octet. All right. So I'm gonna give us an IP address now. And we're gonna work out the increment. We're gonna work out the network ID. And we're also gonna work out the valid host as well as the broadcast ID for each of the networks that we come up with. All right, so given this, working with the same one. So given this particular IP address, what would be our increment? What would be our custom subnet mask? And then we're gonna create a table to show the our network ID, our first valid host, or last valid host, and the broadcast ID for each. I want you guys to go ahead and work out the increment based on what we did last week.
The table is black. Okay. All right, just a minute before we touch the subnetting. Let's just touch back on this. So we look at these. So we have looked at the network ID. So with the network ID for this is what? So for this one, we say it's 10.0.0.0. The network ID for this one is 172.16.23.0. All right. For this, we say that the network ID would have been 192.168.10.4. All right. Let us just do a table for these before I even go into the subnetting. So we can do a table to show what the network IDs are, what the broadcast IDs are, before we even start looking at the subnetting. I don't want you guys to get confused with it. Let me just, so just before we touch the subnetting, let's. All right, so let's look at this. So let's populate a table using those default first. All right, so the first network ID we had was 10.0.0.0. 10.0.0.0. All right. The next one we had was
Just make sure I have them. 172.16.0.0. The next one was 192.168.10.0. Notice these addresses don't come with any CIDR. So we are talking about the default here. If there was a CIDR for this one, it would be a /8, this would be a /16, this would be a /24. Those are the default values. So let's just populate these using the default configurations. I just make it a little bigger so you can see it clearer. What did you write down for the broadcast ID for this one? What's the broadcast
10.
address for the first one? 10.1.
10.255.255.255.
All right. And for the next one, what's the broadcast ID?
172.16.255.255.
All right, 172.16.255.255. And the third one?
192.168.10.255.
All right. So for this network, 10.0.0.0, this is the broadcast ID or the broadcast address. So if you want to send out a message to all the computers on this network, on the 10.0.0.0 network, the address that the router would use to send out a broadcast message is this address, the 10.255.255.255. That's what it would use to send out the broadcast address. For the 172.16.0 network, that 0.0 network, if a message is to be sent out to all the hosts or all the machines on this particular network, go ahead, Dwayne. See your hand raised.
Just out of curiosity, sir.
Mhm.
If I was to ping the 10.255, the broadcast ID, would I get a reply from every computer on the network?
No, this is what the router, this is used by the router
Okay.
to send out the message.
Okay.
If you want to, so for individual machines, you would ping their particular IP address. All right. I remember also that the router would actually keep a track of the different machines and so on. Your particular machine wouldn't do that. All right. So for this one, the 192.168.10.0, if you want to send out a message to all the machines on this particular network, you'd use this one. All right. All right. So what are the valid hosts? What are the valid hosts for each? So the valid host is going to be the number just before, the first valid host is going to be the number just after the network ID. And the last one is going to be the number just before our broadcast ID.
Say that again, sir. Valid host.
So the first valid host is going to be the number just after. The first one is going to be the number that comes immediately after the network ID. And the last valid host is going to be the number that comes just before the broadcast ID. So in this case, what is the first valid host?
10.0.0.1, sir.
Good. So our first valid host in this case would be 10.0.0.1. That's the number that comes immediately after the network ID. All right. The number that comes immediately after the network ID. What's the number just before this number? Just before this broadcast ID?
10.255.255.254.
Right. 10.255. That
255.254.
0.1. Okay. And our last valid host.
172.16.
172.16.
That 255.
That 255.254.
Exactly.
Okay. All right.
Right. I'm not sure why we had it twisted a while ago, but
Okay.
that's it. For this one is more straightforward. We also only have one looking at. So it's 192.168.10. What's the next number? For the first one, that one, and what's the last one?
192.168.10.254.
All right, yeah, that's it. All right, so that, I hope that resolved the confusion. Anybody's not clear, still not clear? Anybody's confused? It's a little tricky when you're working with two octets. I know it's quite easy to get it twisted. Anybody not clear? Anybody still not clear?
Clear.
Clear, sir. Clear.
Clear? All right. All right, so this is the default setting. So there's no subnetting taking place here. So our network ID is here, our broadcast ID is here. We say the number just after the network ID is the first valid host, and the number just before the broadcast ID, which in this case is a 10.255.255.254. It comes just before the broadcast ID. All right, so after we would have increased this, we would have gotten this one. The number just after the network ID in this case would have been the 172.16.0.1, and the number just before the broadcast ID would have been this one. All right, so that's
So sir, question.
Yes?
All broadcast ID would have end with a 255, just for clarity.
Yes.
And for the first valid host, it would end with a 1,
When we
right?
are when we are dealing with the defaults, when talking about the defaults, yes.
Yes.
Yeah.
Okay.
But when you're doing the subnetting now, it's only the very last network will have a 255 as its broadcast ID.
All right.
Thank
you.
All right. All right, so let's shift gears now a little to the subnetting that we looked at last week. All right, so look at these. All right, so if we're given this class C IP address, and we have, say, 192.168.10.4/26, what is the custom subnet mask for this one?
255.255.255.192.
All right, so we actually worked this out earlier on. So the custom subnet mask is equal to 255.255. Everybody's clear how we got that?
No, sir.
No, sir.
All right, remember it's the same thing we did a while ago. What does /26 stand for?
And 26 bits.
All right, so with the first 26 bit on, which number do we get?
We'll add the 8 ones in the first octet, another 8 ones, another 8 ones. And then in the last one, we'll add 2 ones followed by 6 zeros. That's how we got the 192 at the end.
Right. If you're still not following, let me just type it on the screen. So we have 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 3 8s 24, 25, 26. 1, 2, 3, 4, 5, 6. So that's it. That's the binary number that we would convert to get this. So with the octets with all ones, gonna be 255. This is all one again, 255, all ones, 255. And we convert this to decimal, we get 192. Is that clear?
Yes, sir.
All right. So what we're doing now is subnetting. How do we get the increment? What's the increment equal to?
Your
We
minus.
take away 192 from 256.
All right, so 256 minus 192, and that's gonna give us so much.
64.
All right.
Sir, one
Yes.
thing though. Where we get that magic 256 from, sir? Why 256?
Yeah, good question. Because we're talking about 8 bits.
Yes, sir.
And how much space can we arrange the 8 bits?
Now a clue, sir.
2 to the 8 is how much?
Oh, 56.
256, sir.
All right. And also, if you want to look at it another way, just look at the fact that each octet is made up of 8 bits. And there are 256 different ways that you could arrange them.
Okay.
All right. And so we use the 256. So we take out the value that we would have gotten here in the 4th octet from the 256, and that tells us the space that is going to be between the different networks that we are going to be generating.
So it tells you how many. So so it tells you the. All right, work it out in my head now. So it tells you how many ways the whatever remaining bits can be arranged. Is that it?
The you're talking the 64?
Yes, sir.
Right, because that's another way to look at it. If you look at 2 to the 6 is how much? The other 6 bits that you can arrange for the host. Because remember, we use 2 out of the last 8 bits for the network. So we are left with 6
Mm-hmm.
And 2 to the 6 is 64 as well.
Okay. All right.
So you can look at it that way too.
Okay.
All right, and those 6 bits are what we have available to be arranged for the host portion.
Okay. Yes, sir.
All right. How do we work out the number of networks again?
The number of networks, the amount of bits, 2 raised to the amount of bits that are switched on.
In which octet?
In the host octet, sir. Not the
Which
host
of the
octet,
octets?
in the network octet, whatever is being used to represent.
No, not the network.
4.
Something wrong with this word? Subnet. Oh, okay. So let me just type it back. /26 again means, let's type what that on the screen. So the /26 means that we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so that's what /26 means. So what we're gonna do now to work out number of networks, look in the 4th octet. For class C, look in the 4th octet and look at the amount of bits that are turned on.
Okay.
How many bits we have turned on in the 4th octet?
2.
2. So in this case, we're gonna say 2 raised to the 2. So 2 raised to the 2 is gonna give us 4. That means we have 4 different networks that's gonna be generated from this
So, sir,
subnetting. Yes?
in my headspace, I say like 2 raised to the number of borrowed bits.
Mm-hmm. Yeah, that's fine if you want to look at it that way. So you'd be borrowing, in this case, you'd be borrowing from the 4th octet. So it's gonna be 2 to the 2.
Yes, sir.
All right. All right. How many valid hosts are we gonna have per network?
So 2 raised to the number of bits that are off. After borrowing.
All right. Good. Exactly so. So again, you look at the amount of bits that are on. So in this case, 1, 2, 3, 4, 5, 6, 7, 8. How much is that? 2, 3, 4, 5, 6, 7, 8. All right. So look in the 4th octet, look how many bits are turned off. In this case, we have how much turned off?
6.
6.
6. All right, so the number of valid hosts, the valid host per subnet is going to be equal to 2 to the 6. But we have to take out 2 of them. One is going to be reserved for the network ID. One is going to be reserved for the broadcast ID. So it's that number minus 2. So therefore, mean the number of valid hosts per subnet is going to be, we'd have gotten us 2 to the 6 is what? 64? Minus 2. So you'll end up with 62.
Yeah.
Are you following that?
Yes, sir.
So what we're saying here is that the host portion of this network is defined in the last 6 bits of the 4th octet. And since we have 6 bits there to be manipulated, these 6 bits can be arranged 64 different ways. But because we have to take out the network ID and the broadcast ID, that's how we end up with the 62. So there are 4 networks, so we have enough space to put them in. All right, so the first network in this case is going to be network 0. So network ID is 0, that means the network ID in this case is going to be 192.168.10.0. That's what I mean by the 0. And we are going up by 64 each time. Remove this. All right. So we're going up by 64 each time. So after the 0 one, the next one we have is going to be 64. What's the next one? After 64?
128.
128.
And the last one is what?
192.
192.
192. And the next thing that you should observe is that the last one will always be the same number as what you have here. Any number that you have here is going to be the last one. All right. So the actual network IDs that we have, based on this IP address that we are given, so the actual network ID, if we were to type it out, it is fine to just put 0, 64, 128, 192. But if you feel better typing it out, in fact, if you're gonna put it on packet tracer and enter it into the router, you need to type it out. So it would be 192.168.10.0. And for this one, so the default part of the network remains, it's just a subnet. So it's like we just borrow part of the host and use for network. That's how the subnetting comes in. So all of them will have the same 3 octets. But what is going to tell you that subnetting is taking place is the CIDR. Once you see the /26, if the /26 wasn't there, we would actually take it to be the default settings. All right, so those are the networks. So now we have 4 different networks, which therefore means that the computers in this network cannot, oh, you're not seeing my cursor. The computers in this network cannot communicate with the ones in this one without the use of a router. If you have computers on network 192, they can't communicate with network 164 without the router. So the router is needed for that. All right, what's the broadcast address? In this case, the broadcast ID for the first one.
One 192.168.10.63.
That 10 that, all right, so it's a number now just before the next network ID, which is 63. So it's, as I said, it's slightly different now when you're doing the subnetting. If we were not subnetting, the broadcast ID would have been the 10.168.10.255. But since we're doing the subnetting now, the broadcast ID is the number just before the next network or the next subnet.
Hold on, sir. Let me jot this down. This is where I was last week. Hold on. All right, say that again, sir. When subnetting.
Right. So when you're subnetting, the broadcast ID is gonna be the number just before the next network, or the number just before the next network ID.
Thanks, sir.
All right. All right. Let's continue. So what's the broadcast ID for the 64 network?
192.168.10.127.
All right, so the number just before. For this one, for the third one,
192.168.10.191.
191. And the last one,
192.168.10.255.
right. So the last one is always that 255, the very last one.
Mhm.
All right.
Each
So
of them
what's
is incremented by 64.
exactly? So if you check the number between them, you realize it's 64.
Mhm.
So what's our first valid host?
That one.
And our last valid host?
192.168.10.62.
Right. 192.168. Our last valid host?
6.126. Got 129. $190.
All right. And for this one, the last one, 192.168.
10. 193.
This
The other one
one.
is 954.
Yeah. All right. So that's what we would have if we're asked to complete the subnetting for this particular IP address. So what the following?
Yes.
Any question? Any question? Anybody not clear? All right, I'm gonna give you one more of the same
Sir,
class C, yes?
it's not that I'm not clear on this. I'm just asking for, so if you have a network and you set up your IP 192.168.10.64 on one machine, and you have 192.168.10.128, you said those two cannot communicate without a router?
Yeah, all right, let me just clarify. All right, the only way you can put this on a computer if you're not using the /26. In other words, if you're not using the subnet mask, if you're using this as a subnet mask.
Oh, sir, that's not what I meant. I know that these are network IDs. I was
Right.
just I should have gone over to the first valid host.
Right. So if you put this on one machine
and 129 on another.
Right. If the subnet mask is this, then they can't communicate. However, if the subnet mask is the default subnet mask, they can communicate. That means they would be on the same network because the first three octets are the same.
Okay.
But once you put this as a subnet mask, they cannot communicate without the router.
Oh, I was wondering why. Thank you.
Yeah. Mhm. And if you try it in even packet tracer, you'll realize that it doesn't work. It won't work. All right. All right. So let's try another example. You guys will work on this one though. Oops, sorry about that. All right, so let's say we have this network. This time a slash 27. So you're gonna just work out about the same thing for a slash 27. You're gonna work out the increment. You're gonna work out the network, number of networks, the valid hosts, and all of those things. All right, I'll bring it up in a screenshot. All right, so work out this. Same procedure. It's a class C.